Alright, I'm going to show you how to derive the unit circle. So let's start off by drawing a circle. Here's my x-axis, here's my y-axis, here's the center, which is 0, 0. So this point right here at 0 degrees would be the point 1, 0. This point right here at 90 degrees would be 0, 1. This point right here at 180 degrees would be negative 1, 0. And this point right here at 270 degrees would be the point 0, negative 1. Now, let's first start off by looking at the angles that are associated with 45 degrees. So if I create an angle here where I sweep out to 45 degrees, okay, I want to figure out what this point is on my circle, what my x and y coordinates are. So for right now, let's label this as x and y. That's what we're trying to figure out. So to do this, we're going to use some knowledge of geometry, and we're going to use Pythagorean theorem. So what I'm going to do is I'm going to drop down and create a right triangle. So if I pull that right triangle out of the circle to look at it separately, here's my right angle. I'm not very good at drawing, sorry guys. Here's my 45 degrees. This side right here, my hypotenuse, sits opposite my 90-degree angle, is my radius. And since this is the unit circle, my radius is 1. So I'm going to label this side as a length of 1. This side here, I'm going to label it as x. From here out is x, and up this way is y. So here's my x, here's my y. Okay, now we all know from geometry that all the angles of a triangle need to add up to 180. So if I've got 45 and 90, this other side here also has to be 45 degrees, which tells us that this is an isosceles triangle. And when we have a right triangle and we have two angles that are same on the other two angles here, that means the length of these legs here and here have to be the same. So I can label these as the same length. So if I call this x, I'm also going to call the other side x. So even though I started off calling it y, I'm going to say that y is equivalent to x because these legs have to be the same length because this is an isosceles triangle. Now, using Pythagorean theorem, I know that one side or one leg squared plus the other leg squared is equal to the hypotenuse squared. So I have x squared plus x squared, since both sides are x, is equal to 1 squared, which is 1. Then I have 2x squared. When I combine my two x squares, is equal to 1. Then I can divide both sides by 2, so I have x squared is equal to 1/2. And then I square root both sides, and I get x is equal to the square root of 1/2, and I don't want to forget my plus or minus. Now, when I rationalize that, I get plus or minus the square root of 2 over 2. And that will be my value of x. Because we're looking at the first quadrant, I know my value should be positive. So I know x should be the square root of 2 over 2. That's my x coordinate. Now, my y is going to be the same as my x because we said that this was an isosceles triangle. So my y is also going to be the square root of 2 over 2. If I repeat this pattern around the circle, if I come out here to 135 degrees, if I sweep open, here's 45, then here's 90, and then here's 135. If I sweep open to 135, this is going to have the same ordered pair, except for the fact that there might be some sign changes because I'm in a different quadrant. In quadrant 2, my x should be negative, so I should have minus the square root of 2 over 2. Okay, my y would be the square root of 2 over 2. Now, if I repeat that and go around the circle to 225 degrees, this point right here should have the same x and y values except for sign changes. When we're in the third quadrant, x and y should both be negative. Then if I swing all the way open to 315 degrees, that point should be positive square root of 2 over 2 and negative square root of 2 over 2, because in the fourth quadrant, our y is negative and our x is positive. So those are all our ordered pairs on the circle for angles that are associated for 45 degrees.